Hello and welcome to Career in Economics. Today we will start our first model in oligopoly, which is the Cournot model of duopoly. Duopoly means two firms. So we will consider two firms. We will alternatively call them 1 and 2 or A and B. The decision variable of both the firms is quantity, so Q1 comma Q2, or sometimes I'll write QA comma QB. We are interested typically in the equilibrium output, so how the output decision is taken and what quantity is chosen on what basis. We are interested in oligopolistic interaction. Okay, now this model, it came out in 1838, and the approach that was then taken is the isoprofit curve approach. We will see what those things are. But this approach has some inherent problem, and the problem is that it adds a sort of dynamic nature to the models. So they become quasi-static models and not really static models, something which is common to the microeconomics that you study in graduation. Alright. So later, to adjust or to solve this problem, we have taken the game theoretic approach, obviously, which is complete, and the Cournot equilibrium became the Cournot Nash equilibrium. Cournot Nash equilibrium. So typically here we apply the idea of Nash equilibrium in the setting of Cournot model, and we see what is the result. Thankfully, the equilibrium output, that doesn't change, and our problem, that is the problem of analysis, that gets resolved. We will see that later. First, we will start with the classical version, so to say, which is the isoprofit curve approach. Okay. Now, the classical version, if I say so, it can be dealt with two approaches. One is identical or homogeneous products. As far as the model is concerned, it doesn't create any problem. But just let me tell you that these two words are not really synonymous. Okay, they are not the same word. And the other is the differentiated product. Okay. Now here, for the analysis of the model, we will study this, and this one will be taken through problem solving, because the extra component of this is a little bit more calculus. Other than that, everything is same. Okay, so to start with, we'll start with this one, and now we come to the assumptions of the model. So assumptions, let's say, yeah. So number one, two firms with identical products and identical cost. Okay, now what kind of cost? If we go to the Cournot version, then Cournot version said zero cost. But we are interested in where the MC appears in the final answer. So we assume MC equal to C. Number two, the inverse market demand curve is linear. That is, P equal to A minus B Q, where Q is equal to Q1 plus Q2, and A comma B both strictly positive. Okay. Number 3, and this is the most important assumption of the model, which is that conjectural variation is 0. If I write it in calculus, then it will look like dq1 dq2 equal to 0 and dq2 dq1 is 0. In general, we write it like this: dqi dqj, obviously I not equal to j, is equal to 0. Now, this is new. This was not there in monopoly. This was not there in perfect competition. So this is special to oligopoly. What is it? First, let us look at the word conjecture. Now, conjecture is not a theorem. Conjecture means sort of, you think that it will happen, but you cannot prove that it will happen always. Okay? So to give a clear idea of what this is, in oligopoly, we talk about perceived interdependence. Okay? So there is interdependence, but that interdependence may exist not in a real sense, but in the sense that if both the firms believe that their output is interdependent, then also they can start with this interdependence. So this is perceived. Okay, so in the perception this exists, and that's how it is being played out in reality. Okay, that can be a chain. Otherwise, there can be real interdependence, which they conceive and they play out. Okay, so conjectural variation, keeping aside all these complex things, it basically means that if firm 1 today announces its output decision, then based on that output decision, how will firm 2 change its output decision? So basically we are talking about response. Okay, we are basically talking about response or reaction, whatever you prefer, response or reaction. So firm 1's reaction to the output decision of firm 2 and firm 2's reaction to the output decision of firm 1. That's what we are talking about. So this is called conjectural variation. So you listen, so firm 2 knows here's Q1 announced by firm 1 and changes its own decision of Q2. So variation. We are assuming that conjectural variation is 0. That means my announcement of output doesn't affect your decision of output, and your announcement of output doesn't affect my decision of output. That's what it means. We will see how this thing plays its role in the model. Okay. Now, let us just write that in English so that we can understand it in a more kind of economic sense. Okay. So in English, this means while announcing its own output decision, a firm will assume that the other firm is not going to change its output. Okay, so that's what it means. Last assumption, which is the kind of necessary assumption, that is each rational firm is a profit maximizer. So typically speaking, here the problem of each firm is to maximize profit against the quantity. So the problem we are looking at, it will look like something like this. So max Q1 pi 1 and maximize pi 2 against Q2. That's what it looks like. But here comes the difference. Here this profit function will be a function of Q1 and Q2. Here also this will become a function of Q1 and Q2, and this is the big difference. This is where this comes. Okay. Now we must need one instrument so that we can map the response of change in profit of one firm due to the change in output decision of the other firm. And we need that response for each firm. Because of that, we will start with something called isoprofit curve. Okay? So let's see what isoprofit curves are. Just to mention, this is again that point from where the game theoretic approach also starts, which we will deal with later. Okay, so isoprofit curves. First, definition. An isoprofit curve for firm A is the locus of points defined by different levels of output of A and his or her rival B, which yield to A the same level of profit. So we got our name correct. Iso means same, and profit something like iso quant, iso cost, iso profit. But the curves are very different. So here we will draw the isoprofit curve for firm A, and here we will draw isoprofit curve for firm B. QA, QB, 0, QA, QB, and 0. Alright, so for firm A, okay, so as if the top is moving towards this line, and if you can see this, you are understanding the diagram correct. Okay, now here some interesting thing to note. For example, take this output QB naught. If I draw a line like this, look at how many levels of quantity of A it touches, right? There are so many quantities, so many. But as we are saying, that obviously only one of them is optimal for firm A. And our job is not only to find the optimal for firm A in response to some output of firm B, but also of B for A. Okay? So some are on the left side, some on the right side, some are of higher quantities, and as you will see, some belong to lower profit also. Now firm B, so like this. Okay. Yeah. Yeah. So it's going in that direction. Here also you will find the same thing, just to mention, right? So if I take some QA naught, it will go like this. So too many choices for farm B, and only one of them is optimal. Alright, now we will move on to the properties. We'll just state them. We're not interested in how they are coming by. You can intuitively understand them. Okay, so properties. Number one, isoprofit curves for substitute commodities are concave to axis along which we measure the output of the farm. Alright, so you can see here that if I talk about farm A, then his isoprofit curve is concave to A's axis, that is QA, and for B it is concave to QB. Alright, now let's go to property 2. The reason I am not actually erasing these diagrams is obviously that they will be used. Okay, anyway, so the further the isoprofit curves, okay, lie from the axis, lower is the profit. Okay, now number 3 is that for farm A, so we are being specific, for farm A, the highest point for farm A, the highest points of successive isoprofit curves lie to the left of each other. You can understand why I have written farm A, because for farm B it lies on the right side, right? Or actually you can say also that it will go down like this. Alright, so for farm A it goes like this, and for farm B it goes like this. Okay, we are talking about highest point. Now, this highest points, what does this signify? See, for example, for this QB, it touches this, let's say, pi 4 isoprofit curve, then this pi 3 isoprofit curve, then this pi 2 isoprofit curve. And from the properties, we know that pi 2 is the highest profit, not pi 4, right? Now, if I assume that this is continuous and everything, then I know that there is another isoprofit curve which goes like this, right? Which just touches this point. And this is the minimum isoprofit curve, that is the lowermost isoprofit curve that can be reached by this quantity QB naught. And obviously this isoprofit curve will show the highest profit, because the higher ones comes with lower profit. So the optimal output obviously against QB naught will be this QA naught, let's say, right? And we are interested in mapping them because they will be the response. Okay, so now we come to the reaction curves, which will be derived in this diagram. Okay, so what are reaction curves. Reaction curves and reaction function. In game theory, we will call them best response function. Okay. So reaction curves, or let's say curve, is the locus of highest points of subsequent isoprophet curves of a form. So it's very simple. Let me add like this. Yes. So this becomes the reaction curve for A, and this one here will become reaction curve of B, right? Okay, so that's how they look like. Now, obviously we are interested in bringing them to the same diagram. So, we have completed whatever you have to do before reaching the equilibrium. So, let's go to the equilibrium. So, what is the equilibrium? Let us define that too. Okay. So, Cournot equilibrium. But we'll write diagrammatically, we have derived it, right? So let's just say diagrammatically. So what is it? It is defined as the intersection point. It is defined as the intersection point of the two reaction curves. That looks pretty simple, right? Okay, so now our job is to bring these two reaction curves in the same diagram. So now I'm going to erase this. Okay. All right. So QA, QB, right? Okay, now this is the reaction function of farm A, let's say, and this is the reaction function of farm B. And this is where the equilibrium is. Here is QB star and here is QA star, and there is equilibrium, let's say E star. Okay, so this is my Cournot equilibrium. Remember a very, very important condition, and that condition is that RA needs to be steeper than RB, otherwise this will not work. So we'll see how that will create the problem, but for the time being we'll just see the adjustment process. Okay, how things are adjusted, we'll see only that. Okay, now to see that, let's start with any output level. Okay, so let's say this is let's say our QA naught. Now, given this QA naught, the reaction of B will be mapped from reaction RB. So this will be the reaction, right? Let's say QB naught. So reaction. Then against that, this will be the reaction of farm A. So QA1. And again that will move on this direction like this and this and this. Okay? So this is how we can map the response and see how it is going to the equilibrium. If you try it from the other side, it will also work in the same way. And just to show you, we will take a very small diagram here where we will do just the opposite thing and we will see that things will not work. Okay, so this is QB, this is QA, this is 0. This is our equilibrium, let's say E cap, and for a change we rename. So this is RB and this is RA. Okay, now let's say we take a very output very close to the equilibrium. Okay, so let's say this is my QA naught. Now if this is QA naught, then the reaction for this QA naught will be this QB naught, right? And for this QB naught, the reaction of A will be QA1, right? For this QA1, it will be QB1, and then it will go in this direction. So you can see that it's going outside. So diagrammatically, we have seen that RA needs to be steeper than RB. If the opposite happens, then it will be a disequilibrium. In the next class, we will see how to derive the same thing using calculus, and we will also return to this diagram and see what problem is here of related to analysis, which sort of brings in the analysis of game theory. This analysis, it may look complete to you, but it has a very serious logical issue, all right, which will bring in game theory later. Okay, and we'll deal that in some other class.